Welcome to my YouTube channel. For today's lesson, we're going to discuss about solving quadratic equation by using the quadratic formula. Before we can use the quadratic formula, we're going to rewrite first the equation into its standard form ax squared plus bx plus c is equal to 0. The quadratic formula: x is equal to negative b, positive and negative, the square root of b squared minus 4ac all over 2a. In order to use the quadratic formula in solving the quadratic equation, we need to identify the values of a, b, and c in the equation ax squared plus bx plus c is equal to 0, then solve. For example, we have 6x squared minus 11x is equal to 10. So first thing that we're going to do is we are going to write it in the form ax squared plus bx plus c is equal to 0 by transposing 10 to the left side of the equation. So the equation becomes 6x squared minus 11x minus 10 is equal to 0. And then identify the values of a, b, and c. For the value of a, it is the coefficient of x squared, so a is equal to 6. While b is the coefficient of x, so b is equal to negative 11. And c is the constant, which is equal to negative 10. Next, we have the quadratic formula. X is equal to negative b, positive and negative, the square root of b squared minus 4ac all over 2a. Then substitute the values of a, b, and c to our formula. So the formula becomes x is equal to negative multiplied to negative 11, positive and negative, the square root of the square of negative 11 minus 4 times 6 multiplied to negative 10 all over 2 times 6. Then we simplify. So we have x is equal to negative times negative 11 is equal to positive 11. Then positive and negative, the square root of the square of negative 11 is equal to 121. And the product of negative 4, 6, and negative 10 gives us 240. And for the denominator, we have the product of 2 and 6, which is equal to 12. Simplifying it further, we have x is equal to 11, positive and negative, the square root of the sum of 121 and 240 is equal to 361 all over 12. Now we have x is equal to 11, positive and negative, the square root of 361 all over 12. Since the square root of 361 is equal to positive and negative 19, then we have now the value of x as 11, positive and negative 19 all over 12. Now we have two possible values of x. X is equal to 11 plus 19 over 12, and x is equal to 11 minus 19 over 12. For the first value of x, 11 plus 19 is equal to 30 over 12, which can be simplified as x is equal to 5 halves. So we have the first value of x, which is equal to 5 halves or 5 over 2. Next, we have x is equal to 11 minus 19 over 12, which can be simplified as negative 8 over 12. Now, dividing the numerator and denominator by their GCF, the second value of x, or the second solution of our quadratic equation, 6x squared minus 11x minus 10 is equal to 0 is x is equal to negative 2/3, or x is equal to negative 2 over 3. Next example, we have 4x squared minus 8x minus 5 is equal to 0. Since the equation is on its standard form, we are now ready to identify the values of a, which is equal to 4. For the b, we have negative 8, and for the c, which is equal to negative 5. Substituting the values of a, b, and c into our quadratic formula, we now have x is equal to negative multiplied to negative 8, positive and negative, the square root of the square of negative 8 minus 4 times 4 multiplied to negative 5 all over 2 times 4. Simplifying it further, we now have 8 positive and negative, the square root of 64 minus 16, because negative 4 multiplied to 4 is equal to negative 16, times negative 5 all over 8. X now is equal to 8 positive and negative, the square root of 64 plus 80 all over 8. So from x is equal to 8 positive and negative, the square root of 64 plus 80 all over 8 can be simplified as x is equal to 8 positive and negative, the sum of 64 and 80 is equal to 144, denominator is equal to 8. Now x is equal to 8 positive and negative 12 all over 8. Now we have two possible values of x. X is equal to 8 plus 12 over 8, or x is equal to 8 minus 12 over 8. 8 plus 12 over 8 is equal to 20 over 8, which can be simplified as 5 halves. So the first value of x is equal to 5 halves. Next, we have x is equal to 8 minus 12 all over 8, which can be simplified as negative 4 over 8. So dividing the numerator and denominator by the GCF. Now the second value of x is equal to negative 1 half. Next example, we have 2x squared plus 2x plus 3 is equal to 0. So since our equation is on its standard form, before we're going to use the quadratic formula, we have to identify first the values of a, b, and c. And for the value of a, it is equal to 2. For the b, which is equal to 2 also. And for our c, that is equal to 3. And then we're going to substitute it into our quadratic formula, which is x is equal to negative b, positive, negative, the square root of b squared minus 4ac all over 2a. Next step, substitute the values of a, b, and c to our quadratic formula. Then we simplify. Now we have x is equal to negative 2, positive and negative, the square root of 4 minus 4 times 2 times 3 all over 4. Then simplify the terms inside the radical symbol. Now we have x is equal to negative 2, positive and negative, the square root of 4 minus 24. So negative 24 is the product of negative 4 times 2 times 3. And then the denominator, which is equal to 4. Notice that the radicand is a negative integer. So we're going to use the concept of imaginary number so that we can use the square root of negative 1, which can be substituted as I. And then we're going to find a perfect square factor of 20. So now we have x is equal to negative 2, positive and negative, the square root of negative 1, which is eventually be equal to I, multiplied to the square root of 4, which is a positive integer. So with square root of 5, now square root of 4 is a perfect square factor. So over 4. So to simplify, we now have x is equal to negative 2, positive and negative, 2i, because the square root of 4 is equal to 2. And then square root of negative 1 is equal to I. So multiplied to square root of 5 all over 4. Now we have x sub 1 is equal to negative 2 plus 2i square root of 5 over 4. And our x sub 2 is equal to negative 2 minus 2i square root of 5 over 4. Then we simplify. X sub 1 is equal to negative 1 plus I square root of 5 over 2. And x sub 2 is equal to negative 1 minus I square root of 5 all over 2. So that's all for today, guys. I hope you learned something from this video. Please don't forget to hit the like and subscribe button for more video updates. Thanks for watching.